vehicles. So we have again in our second session in our almost third event during the lockdown and after that. So thank you so much, sir, for being with us. Session is the impact of electric vehicles on electricity demand and distribution. So thank you so much, sir, for being here with us. And over to you.
Thank you very much, Niti ma'am. Thank you very much again for the opportunity that CERT has provided me with, and I'm always grateful to CERT and to Niti and to Dr. Jain, etc., the whole group of very eager staff members at Sagar or CERT, whatever it is called. It's always a pleasure to talk to you people. Today, the second part, I've told you electric vehicles is going to come. Now, with the coming of the electric vehicles, my friend, please understand, it's all right saying that electric vehicle is going to come. But with electrical vehicles, there's going to be tremendous amount on demand on electricity and how we distribute electricity. That will become the name of the game. So let us first see the overview. And the first thing that comes to my mind is in the overview itself. As you can see that there's going to be huge amount of change in technology. Okay. Now, when there is change, my friend, please note, change is good, and change normally brings opportunity. I'll tell you one thing, and that is everyone looks at these changes and they look at these opportunities. But try and understand that sometimes the older generation of engineers do not like these change, especially those who are near the retirement. They don't like all these changes that we are talking about. So no doubt opportunities are there, right? There's no doubt opportunities are there. And these opportunities have come purely because of the necessity. So one can actually think that these changes that we are talking about is very similar to what was mentioned in one question that I had. That IoT, someone asked that question. IoT, I'd rather call it IoE, that is Internet of Energy. These are parallel changes, exactly like IT infrastructure has got IoT. We will have Internet of Energies. Now, what are the technologies? And I'm talking about technologies, right? We're talking about technologies that are changing technologies. The systems are going to change. These are necessary changes. It brings a lot of opportunities. There are a lot of parallels with these changes. What are the technologies? The first technology is ICT, Information and Communication Technology. In the information technology, the things that come in my mind first is smart grid. The infrastructure will become very smart. Then you will also have huge amount of storage. You will also have huge amount of storage. You'll have storage. Where will you have the storage? Will it be in the grid? Will it be the best utilization that we can think of? Where will that be? Okay? Where will that be? Because one thing is for sure, that energy storage will bring in huge amount of renewable generation. And if you look today, we have got 18% of our energy coming from renewable energies. In 2050, we will have 73% of our energies will come from renewable energy. If you look at the figure, 18% is now. It started with 2005. In 2020, we have now reached to 27%. In 2035, we will be 51%. And by 2050, we will be 73%. So huge amount of renewable generation will come. And things like a battery energy storage system, BESS, will be very common. And vehicle itself, the electric vehicle, that will be a storage device too. So the ICT will be there, the energy storage will be there. And as I mentioned early in my first lecture, that this will increase flexibility and efficiency and the resilience of the system. System will become very resilient. We'll be talking about a very high efficiency, 90 to 95% efficiency, and the system will be very flexible. I don't know whether you realize this or not. 1/3 of the energy is consumed in the transport sector. And this sector cannot be ignored. You'll be surprised, and I'm talking about Melbourne now. In Melbourne, we have got in our public transport system, beside the buses, we have got trams, we've got light rails, we have heavy rails, we have got all sorts of system for our public transport system. You'll be surprised. Most of our transportation system has gone out of date. In Melbourne, we have trams. Trams are very commonly used in the city of Melbourne. And most of the trams have become outdated now. And we need to replace 300 trams. The best we can produce is 30 trams a year. So it'll take us 10 years to completely modify our transportation system. In that time, we would like to incorporate new type of transport which can take COVID into consideration, which can take renewable energy generation into consideration. We can take in place things like what we didn't think of, and that is the street of Melbourne is not catered for those large trams that you see in Europe and other places. Here, the streets are narrower, and being narrower, we need 20 meters tram. So we have decided that we will manufacture all these trams in Melbourne itself or in Victoria. So you cannot ignore transport. And therefore, we have to look at the electrification of this transportation. Again, we will be looking at efficiency, compatibility, cost, etc. So now, did we do the right thing by choosing electric vehicles? Did we create a problem? Or did we make it a part of the solution? We were looking for a solution. Did we make that? But whatever it is, whether it's a solution or is part of the solution or is a problem, it has three dimensions. And the two which are very important are technical, commercial, and naturally, without the will of the political parties, I don't think we can at all run. So, Let us look at this, and I don't know how to raise this, but anyway, I'll try it again. No, I don't know how to erase this. This is the beauty. Ah, that's it. So now, let us look at that one question that was asked in my first session, the IoT. And if you look at that IoT part, and we are looking at the Internet of Energy, if you look at it, in the past, in the past, in the past, we had our substation, we have the system operator, and this was our industrial customer, the commercial customer, and the residential customer. As we called it all depended on the BAN, the CAN, and the EAN, that is building area network, the industrial area network, and housing area network. See that we have got some control in the transmission, some control in the distribution. Again, we have those substations like we had before. And again, we have those three types of customers, the HAN, the YAN, and the BAN. But look, in the future, my friends, in the future, in the transmission system, we will have energy storage here. We will have energy storage here. We will have energy storage there. All these are energy storage. And predominantly in the residential, commercial, or industrial sector. And look at that. This is our traditional, this black line that you see is our traditional electrical infrastructure. Now look at this. We have got all the comms that will come place. So all the comms that is coming, all the comms which will be there, look at that. All the comms that is there. So the appliances that we will have will be very smart. They will have controllable loads. They will report the status of the equipment, and they will use the EV either as a sink or as a storage. So the electric vehicle which will be there will be either used as a sink or storage purposes. And if it is that, we can say it is a V2G, which is vehicle to grid. The operation will be very, very smart. Huge amount of reliability. The service connections will be fantastic, and more renewables will be fair. The interesting thing will be the pricing will be very smart. The interesting thing will be the pricing will be very, very smart. The pricing will be very, very smart. Where there will be differentiating pricing. I don't believe that we will have off-peak and on-peak. It'll depend on the performance of your equipment. Is it a 5-star equipment or is it a 1-star equipment? So there will be aggregation on prices. A lot of market participation will be there. And as I mentioned again in my first lecture, I told you There may not be any consumers, there will be prosumers. That means everyone is a producer and everyone is a consumer. So to do that, we need to have a very smart planning. That means we have to make sure that we can defer our infrastructure, we can minimize our cost, and we can minimize the carbon emission. Now, so if you look carefully, I have got a virtuous circle, and look at this circle very clearly. I've got this virtual circle where on my left hand side is the intelligent export, and that's my smart grid. And in this small area that I've got, the three are meeting: the EVs, the electrical energy, and the ICT. So there is the energy which is fundamentally your electrical energy, your exporting, which is done by electric vehicle, and all your communication infrastructure will be based on ICT. Right. Now, as I said, there's going to be rapid growth. There's going to be rapid growth of my PV and electric vehicle and mine. There's going to be rapid growth. There's going to be rapid growth. Electric vehicle and storage. So you'll find that more and more people will be having rooftop PV. And that will be around 33 gigawatt installed capacity by the year 2035. So it will increase by 40% from today's figure. So there'll be huge amount of penetration of battery. Huge amount of penetration of battery. And we are also assuming that 20% of our household will be owning electric vehicles. So by 2035, there'll be 2 million cars running in the Australian street using electric vehicles. Now, this may be required also, which I mentioned in the last one, FCAS, which is frequency control and network support services. So this infrastructure will be required for that because of that high amount of renewable penetration that I have. And these all have to be integrated in our national electricity market. Will have to be integrated in our national electricity market. Now, look at the storage technology, my friend. And this is the interesting one. Look at the storage technology that we have today. And many of us are only thinking in terms of this lithium ion type of battery. You know that lithium ion types of batteries are good, okay? And it can have a discharge time, which is good also. But don't forget, the grid support may be required to come from sulfur-based batteries too. Although a lot of us are using pumped hydro scheme, the compressed air energy storage system, etc. Now, ultra capacity and super capacity might be used as battery in the electric vehicle. But if you look carefully, the storage technology that you have, right, the highest amount of that is in the compressed air energy storage system. And this is the lithium ion one. Okay. And you find that the sodium sulfur we can get compared to the lithium ion that we have today. Okay. This is a very crowded figure, but I just wanted to show you that if you look carefully, uh, all the various steam, most mature steam that we have is the one that we're using today, is the lithium ion one. Okay. And it has a very high efficiency, my friends. Okay. And the sodium sulfur one, we still need to deploy. It will take time. Efficiency is not as good, but the cycle limit is as good as lithium ion one. Now we have to look at the value of electric storage. And you must understand that there are three perspectives. One is, what is the value of the merchant? What does the merchant think, Roy? What does the merchant think? What does the merchant think? What the value merchant brings? Naturally, this is according to the Electrical Reliability Council of Texas, ERCOT wholesale price. Okay, then the energy which is driven by arbitrage will be providing the ancillary service prices. So this is important because it gives you the wholesale market price and well as it offsets the storage cost. Then let us see, this is the merchant value itself. What does the system-wide benefits which are there, which will help the society? And if you look carefully, the Public Utility Corporation or Commission of Texas said that it requires a whole societal or system-wide benefit. Let us see what is the system-wide benefits. That means we have to find what is the total resource cost in the system, which includes production, investment, and outages. And the third perspective is the customer himself or herself. And the customer himself and herself is the most important part because they are the one who will formulate the public policy. Now, every customer wants savings in their bill, and the savings will only come if the wholesale price is reduced. And they want to realize a reliability which is very high. So no one wants outages. Okay. Now, if you look at the value employment that you have, okay, naturally, if it's a smaller system, the impact is the total um, cost is much lower than a very high system. And the storage deployment, look at that, is much smaller. Now, we want to make sure that what the cost we know is the cost of the battery. And you'd be surprised, look at that figure. The cost of the battery is actually going down substantially. And every 3 years, if you look at it carefully, the price have become half. So a stage will come when the price will be is not only on the impact on both PV inverters and installation prices. Now, the storage. I'm telling you right now that we knew 5 years back that battery storage is going to become a huge issue. And we knew that. As a matter of fact, in 2016, we had the South Australia blackout. And that's when we realized that our renewable energy is not enough unless and until we can provide a battery storage. When the whole of state of South Australia was without power in September 2016. So then we got um, Elon Musk to come and build a power station, which he did 100 megawatt lithium ion battery plant that he put 3 months. So this is definitely going to, everyone now is putting similar plant all over Australia, in particular where there's a high penetration of PV or renewable. Okay. So therefore, at the moment, there is a lot of subsidies on this rooftop solar panel, and the utilities are looking at that as a cheaper option rather than expanding the grid. And now, the cost of the electricity. My friends, the electricity cost for PV is going down, right? And unfortunately, the electricity prices for household is going up. The customer is not very happy. Okay, and if you look at the levelized cost of electricity, the LCE price of electricity, if you look at PV, wind, biogas, coal, CCGT, you will find that the prices of the PV is come down substantially. Now, let us look at the price of owning an electric vehicle car versus an internal combustion car. If you look at the two model that I wanted you to look at, one is Leaf. Leaf price, if you look at that, is substantially lower, is substantially lower than what you would have expected. The price of leaf, the price of leaf is substantially lower. Naturally, Tesla is a high price, and this is the S model that I will talk to you about. Okay, but there are tax credit in many countries if you buy an electric vehicle. This will push the ownership of electric vehicle. You need some charging infrastructure, and you need some V2G services too. So this is something that you have to be careful about. That there are, although I've told you the prices, but there are other factors that might come in. Now look at the rapid dispatch and ramping. When I increase my PV installation, my efficiency will increase also. Now, you cannot have a PV, don't have a PV if you do not have a battery. You need a storage to make it more efficient, the system, or else you're talking in terms of 17 to 19% efficiency only. So you need to smoothen a clear sky and you had a PV. This is the type, that dotted line is the type that you will have as your curve. This will be your output of the PV. Whereas the PV output is fundamentally that, the one that you see. However, if you use some sort of method in which you can buffer the PV, you will find it is not very, very bad, but not as bad as the original one. Now look at the city, and that is Asia, the probability is a clear sky radiation and other things depending on other factors. It all depends on which type of day will you use, and that will give you the distance between side versus the coefficient of the change. Again, if you look at the another PV spatial thing, and again, you look, you find that due to variability, you find that the quality keeps on changing. Okay, and the same thing will apply to EV. The same thing will apply to EVs. The same thing will apply to EVs. Now, my next part is looking at that variability. Looking at that variability, okay, if you look at that variability, you find where is the best place that you can put your electric vehicle. The best place you can put your electric vehicle will be closest to the source. Uh, the closest place will be closest to the source. Can you see? That means you can reduce the voltage variation on the line and it has a rapid response time. So this looking at the electric batteries for grid support, and that electric vehicle was providing the support over there. So if you place it closest to the source, you will have the best type of performance. Now, if you look at the sales of the electric vehicle, already we have sold 1 million cars. The top selling model is Nissan Leaf. These are the 10 best cars that are there in the market. See, the traditional cars are no longer there. And the countries which have got the maximum sale, the top 10 countries, is addition. Most of the Europe and the OECD countries, few countries like China and Japan naturally are leaders in the Asian part of the world. So, whether it is in the highway, whether it is for light duty, around the globe you are finding more and more plug-in hybrids roaming around in the car. So 5 years ago, you only had 500,000. And another 500,000 has been added in this 5 years. Now, this is a very crowded uh, uh, thing, but I wanted to show you all the cars which are there. These are all the cars which are there. It gives you all the efficiency, all the various type of changes which has occurred. I don't intend to go to that. I just thought to give you an impression that there are so many cars in the market. Now, the forecast. I think the market is very good. According to ICOM, which is an American company, they said that by 2025, we will be having 1 million cars in our market. We will have 20% of our car, which will be about 1 million car electric vehicle here. In Europe, it will be similar. It's also expected that, according to our IMO, it's also expected that my question is that will EV grow as fast or not? That time itself will say. Infrastructure development, naturally, fueling station or station, that is a very big question mark. But try to understand from 2011 onwards, more and more charging stations are now available. Number of cars have increased. And they will have to incorporate. In the olden days, it was only LNG, LPG, or ethanol-based uh, biodiesel toy. But now there are more opportunities. I think electric vehicle, once it establishes itself, which will be the hydrogen-based vehicle. So that type of charging infrastructure has to be provided. How will we charge our cars? That'll be a big challenge. Okay, now let's look at the requirements. First of all, in hybrid case, for 15-kilometer range, for 15-kilometer range. We have the energy capacity is 1.3. For Nissan Leaf, it is 24 kilowatt hour. Tesla is 85 kilowatt hour. 50-kilometer round trip will take about 10 kilowatt hour, just to give you an idea. But look at that. They have a 400. And the load a source on low voltage for every 1 million electric vehicle, there'll be 10 gigawatt hour daily compared to 14.7 gigawatt hour per day. And the demand will increase from 900 megawatt to 1700 megawatt. So we will be getting more mobile storage in the wheels. We will have them fixed in household, and they will play a very important part in our electricity system because you need to charge your electric vehicle. Okay, the charging standards. Now, I wanted to mention, I always love talking about standards. Many of us forget talking about standards. And there are standards in place. There's IEC 62196 that gives you standard for all the plug, socket outlets, vehicle connections, and other things, right? And in that level, and I told you about that, the GPO charging, that may become outlawed because everyone will be trying to charge at the same time millions customers, and you will find that our system will not be able to cope up with that much demand. Then for the um, charging system itself, that will be IEC 61851, and the vehicle to vehicle grid communication, which is the smart charging, is on ISO 15118. Now, if you look at, I asked you a question, electric vehicle a solution, or is it a solution or is it a problem? Because there is an impact. If you look at it, if the impact of EV charging on power system depends when it is. See, if there is a smart charging, so you do all your charging in the off-peak time. So you do not put the grid into too much of, or if you're going to have huge amount of demand charging throughout the environment. Okay. Now, again, if you look at charging station that we will have, see, this is a beautiful one. The charging is utilizing PV for charging the cars. This is definitely a very environmentally friendly type of charging station. Now, also, I mentioned to you, and I repeat again, I've mentioned to you, it can help to maintain or improve the power quality. That is done by demand management and the source management, where it is V2G. Look at that. This is where the PV hybrid electric vehicle regulator is there in the distribution sub company. That is in the DISCO, not in the not in TSO or on the generator side. So it depends on where it is. And if you look at it, the on the plug-in hybrid electric vehicle. Now, integration. This is an interesting one. This is V2G. Look at it. I have got my electric vehicle. I've got my electric vehicle, my friends. I've got my electric vehicle. Okay. Electric vehicle that is both the ways between the aggregator and there. And this is my charging station. And that charges my electric vehicle. And that's the EV usage. That is one way. The other project could be from electric vehicle to the charging station. It goes to the aggregator and then the EV user. The Berlin, the public charging system is very interesting, where the electric vehicle and the electric vehicle station, they communicate with each other, and the aggregator and the EVSE communicate with each other, and the EV user is the one which talks to the aggregator. So all of them have got protocols and standards to follow. I have given it to you there. Now, the information flow, the best example that I can think of when it's a two-way street, when you can do V2G or V2X, vehicle to anything, not only household, vehicle to infrastructure, vehicle to vehicle, anything. Now, the communication. If you look at communication, look at all the standards that come into play. All the IEC standard, the IEEE standard, especially my favorite one, 802-11, which is the wireless comms one. Okay, all the standards come into play. And whether it is for EVSE, whether it's an aggregator, whether it is for electric vehicle service provider, with an electric vehicle system supply equipment, whether it is for the battery management system or the electric vehicle, everything has got V2G. Now, if you look at this, the business model, and the business model is interesting because the business model, you can't run the program. This is your business model, where you have the operator, energy management operator, that and the transmission center, and they talk to the final customer. And these are all the various type of participants which are there, which is the electric vehicle charging point. These are the charging points. And exactly in the same manner, you've got a management where the market talks to the EMS, DMS, and it talks to the board. And the physical layer is the one which you might be interested in, based from the transmission grid all the way to distribution grid, and that goes to the charging infrastructure. This is the cooperative charging with park and strain. And these are the various electric vehicle charging points. The business model is such that you will find that there are costs in every factory. Who owns the vehicle? Does the business model include the price of recharging? Who bears the risk to the business model? Does this business model resolve the issue of range limitation? Does the business model changes the way people drive and their attitude? And depending on that, you can find various types of scores which are given after consumers have been surveyed. Now, I want to mention about some of the example of domestic storage management. There is one company called Deposit Power. They are the aggregator. They do the energy trading service. They provide services also. They do all the energy market. And if you look at the how they are saying that they will. This is in Canberra. They will double the saving with the new technology that they will provide, which as reposit power. So they give out grid, grid credit technology by using the Tesla home batteries. The other one, which is the interesting one, is the one which is done by Ergon and Arena. Arena is our Australian Renewable Energy Association, a national association. Ergon is a distribution company in Queensland. They have got virtual power plant. They have got their own information system, which is where the asset is owned by Ergon and the assets are leased to the customers. And there are savings to both the customers, the benefit is to the distributor. So you can either do solar optimizing. Look, if that is cut, then the home is supplied. If that is cut, then the dollar flow, and this that happens. So this is the demand response, the price response, the grid when it becomes interactive, and this is the optimized solar. The energy storage technology, as I have mentioned to you, that I've mentioned to you about sodium one versus the lead acid one. You see that the installed capacity is practically similar, but for wind integration, which is very commonly used, it is better to use a sodium sulfur battery rather than the lead acid battery. And you can see vehicle to the value when you talk about vehicle to grid integration, we talk about this vehicle to grid integration, my friends, then you will find when you look at the vehicle to grid integration, you find this could give me $21 million by 2024. And at the moment, looking at the car today, it is a fraction. But by the time we have millions of plug-in vehicle in our market, in big business, and many business will use VIG technology, which will exceed $20 million within the next 10 years. The integration itself, the grid integration, because here the EV owner is a consumer of product. I told you in the beginning that they are prosumer also. They subscribe and they charge their service and they use just as similar like a mobile phone. So EV's own charging is packaged. You get value added service which is provided through the aggregate and services to the grid. So I told you the EV owner is a prosumer, which is producer and consuming. So this is where IoT, as was mentioned in the first question, which I'm saying IoE, which will be the EV will be owned, the charger will be owned or leased, energy will be traded, and that will be the services that will be given. Either it will be V2G, V2X. And the fourth model will be that no EV ownership. which will be in transport and the energy services. This is just 4 of the list that I have done, right? You can also think in terms of Uberization, we can think in terms of Uberization. Liberalization, why not Uberization? So we can think in that term too. It all depends on how you play your relationship between the individual owners, between the aggregators, the retailers, and the distributors. So I want to show you 3 business models. One is a Model S, which is Tesla Model S that I was talking to you about. After incentive and petrol saving, it will cost you $1,700 per month. Very fast charging time. And it gives you a model with a financial model with like this. The second, where the app says the driver, public will pay as you go. There are membership for premium services. You can have it at the home also. You can have it at your home when you can have a charging point, and you can. So there are 3 points. One is the driver, the other is at home, and the third could be the business when it could be fleet charging. Then the third model I wanted to talk about is EVGO, where there'll be infrastructure and unlimited charging, either at your home, mobile, or it can be complete. Then a better place model, where this is the company that is there, is talking about charging. There's the battery switches, all the services. These are the charging done, and battery swap is done, which is done in 4 minutes. And this gives you. Now, the other model is Nuvi, which is V2G. And here you see that there is two-way communication to your EVSE and to the aggregator services. And this brings value to many of the players, not only to the original equipment manufacturer, but the car owner, the TSO, the ISO, DSO, and the society. Everyone is a winner. Then again, this one, the Nuvi one, the monthly is about $150. Electricity cost is about $40. Profit is about $110 per car. So it's about $2,500 car. So you can plug your car, either you can charge the battery to 50%, or you can switch to V2. And lastly, get ready for your next trip. Then the one which is in France, they are looking at both the individuals and the businesses, and here they are giving you a return in a very short period of time, where they talk about e-mobility in urban metropolis. So, in conclusion, I wanted to mention that I wanted to mention that there are technical as well as commercial into your distribution requires storage. And as I told you, this must be close to the source. The comms have to be good. ICT and the grid will become very smart. And load. EV is definitely a large part of the solution for any increased penetration of your distributed renewable energy system. Commercially, there are multiple participants in the market. They've got different roles, and there is a lot of opportunities for business model so that there's cost benefit to everyone. If you remember, I showed you a virtuous circle Now, I have just added that bigger circle. This is what I showed you. Now I've got everything in that bigger circle, and that's what it is. Everything will be encompassed into intelligent export and a smart grid. Delhi has, if you remember in Delhi, and I'm sure you people must be going to Delhi, which was full of pollution, and it has solved this. I've seen this electric rickshaw driver, and they are there to clear outside a Delhi metro station in New Delhi. These are all electric e-rickshaws. Look at them, they're waiting for passengers. These are all e-cars. These are no longer the CNG ones that we normally used to see in Delhi, which were causing a lot of pollution. I don't know where it came from, but we have got 1 million electric rickshaws in Delhi. You've got 1 million electric rickshaws in Delhi, and it's used by 60 million people a day. And that 3 minutes over time, Niti.
No, sir, it's absolutely fine. We are getting benefited from your lecture right now. So thank you so much, sir, for the wonderful session. I think you have covered the economics and technical part also. So now we are, I think the participants have got much knowledge about the business. Everything, every technical thing and non-technical thing, management side, everything are very well, sir. So thank you so much. If you can take the questions that have been asked in the previous lecture, if you have time.
Okay. Whatever you want to do, Niti, if you want me to go, I will stop. It is very late in the night, my place, but anyway, uh, I could go and have my biryani or whatever I'm supposed to have. And uh, if there are some 1 or 2 questions, I don't mind taking it. But as I said to you right in the beginning, electric vehicle is going to change our life completely. And remember, whether you like it or not, you will be having electric vehicle at your home. Anymore IC, internal combustion engine cars. Now it is quite possible that Niti, you might be driving your electric car to CERT in Bhopal, and you will try and use your boss's electricity and charge your car there and run the electrical labs by using your storage device as your car. It is quite possible, but I'm sure Sagars will fire you the very next day. So please don't try that. So
Yes, sir,
I don't think that would be allowed.
um,
Charging for cars will be
let's,
depending on like a credit card.
yes, sir, definitely. Where the technology takes to us in next 5-10 years. So in short, we have so many covered already in your presentation. So I'll be taking one or two if that some of the questions. Okay. Standard for voltage, current, power, and frequency for V2G and V2B technology.
Sorry, the standards? The standards?
Is there any specific standards for voltage, standard voltage, current, power, frequency for V2G and G2V? Somebody is asking.
Yes, yes, there is. As I have given you broad standard, I've given you the 3 IEC. There is a whole section on
Yes, sir.
IEC which talks about the voltage, the current, and the frequency. Naturally, fluctuation more than 2% will not be allowed on voltage and frequency. No doubt about that. So you cannot have huge fluctuation. Penetration of solar one brings in a lot of fluctuations, and we will have to make sure that we control it when we are putting it to our equipment on our home side or residential side or in our commercial side. Because nowadays we have got precision equipment, we work with precision equipment. You cannot allow such distortion to enter your equipment, or else very expensive equipment will be destroyed. That is why there'll be a lot of games to play for power electronics. Power electronics will play a big part in making sure that you convert it, use DC to AC conversion, and try and reduce these levels to bare minimum.
Okay, thank you so much, sir. Most of the questions which has been asked by, I have just gone through the questions. Most of the questions of your sessions already. So I request all the participants to please go through the Google link again if you have missed some of the all of your question will be answered by seeing the YouTube link again. And if you have attended the lecture very keenly and observantly, then you find your solution already. Thank you once again. Thank you is not enough. For your kind generosity, which you always shows to us. So I just like to share a certificate, which is in the form of gratitude. I think, Amit sir, can we see the? I think there is some problem. Just a minute, I will share it again. Okay. I'm trying to share your certificate.
Yes, I can see it
Okay.
now.
I think.
Yeah, thank you very much. Very good. Thank you very much.
Thank you so much, sir. I'll be mailing it to you. So thank you so much again for connecting with us, sir. Thanks for listening to the very eminent speaker of electric vehicles, Dr. Akhtar Kalam, sir. Thank you, everyone. Signing off.
Thank you very much, and
Connecting
namaskar to all
tomorrow
of you.
at 1 p.m.
Namaskar to all of you, and Jai Hind. Bye bye.